All right, so questions.
Oh, really? I didn't think it was
For PA2, can you explain about the SPIN again? Is it same as C?
PA2?
Yeah.
Yeah, so standard in, you can get to it basically with system.in. And yeah, it's the same as what we've done with C. It's usually what you're typing on your keyboard, that's what's feeding standard in, or system.in in this case. But if you run your command like Java PA2 less than file name, the contents of that file basically supply input to standard in. Or if you say command pipe into Java PA2, the output of that command will go into standard in.
Okay.
So you've got different ways to feed that stream.
So this PA2, we are reading from a file, or we reading from the keyboard?
You're reading from standard in, which by default is the keyboard.
Okay. Are you going to be typing in a text file into it?
Possibly. It shouldn't make any difference to your program, though. Right?
Like
your program just reads from system.in, builds the index, and when it hits the end of the file, which you get by saying has next, comes back with false, then you print out the index and you're done.
The thing is, we're reading from a keyboard.
Mm-hmm.
How does it know when the user's done typing?
From a keyboard, if you hit Control-D at the beginning of a line, that signifies end of
Oh,
file.
so it's the same.
It's exactly the same setup,
Okay,
yeah.
I see. Okay.
Except in Eclipse, sometimes it's Control-Z. But on the Linux system, it's definitely Control-D.
Okay, I see.
Eclipse, some setups sometimes want you to hit Control-Z in that console window. But let's just find out. So this is a good Eclipse run through. Straightforward. So we'll just read from system.in, we'll echo the input until we hit the end of the file, and it'll give us a message to let us know it hit the end of the file. So if we run that, here's our console window down here. So I can say this is a test and it prints that out. I can say goodbye and it prints that out. So if I hit Control-D, that says end of file detected. So that should be good.
How would you read in a file?
Yeah, how would you
Oh, from here? Oh, yeah, so, yeah, I do know how to do this. But I'm drawing a blank at the moment. I'll find out and get back to you. It's a real obvious way to do it, but I don't know at the moment. I'll figure it out.
If they do keyboard shortcuts like you can, and you can't just do Control D, you're in one.
No, where the question was how do we redirect standard in
Oh,
from Eclipse? And I definitely know how to do it, but I don't at the moment. So unless someone knows, I'll figure it out. Okay.
What to do with navigate now?
This is where I say, here's a homework question for you. All right, I'll post that on our discussion or an announcement. All right, other questions?
I guess for PhD, is there a specific reason why the word list and position list constructors take in no arguments?
Why the constructor for position list takes no arguments?
Yeah, word list. Because it said constructs with no arguments. No.
What would you like to give it?
Well, I already wrote it in the works part of constructors.
Okay.
But
I mean, you could make a constructor that you pass the integer value that's going to go into the first node, right? That might be useful because you don't actually construct this until you've got a node to put in. But that may confuse people. If you want to do that, that's okay, because I didn't put this in here, but your position list can technically be private, or at least private too, right? It's not going to be called by the main program. It's going to be used by your word list, but you're not really giving position list to the user. So if you use that in some different way, like having a constructor that takes the first number, that's fine. It's not going to trip anything up. Other questions?
we can add more methods than we just specifically.
Definitely.
Okay.
Yeah, and you will definitely want to. And you can add more classes, right? And you at least want classes for the nodes of your to list, but you may want some other classes too, and that's fine. I'm just sort of giving you what's required. All right, anything else? So let's talk about linked lists in Java. And I'm not going to do a linked list that you can actually use directly in PA2, but I want to go through the implementation of a linked list that will give you some idea how to sort of take the data structures we did before and port them into Java. So let's make a linked list of rectangles. How about that? Because that's kind of non-222-ish. So we're going to have our standard linked list. Like that. But each of these pieces of data is going to be a rectangle. All right, so this whole thing is going to be an object. Everything's an object. The data piece of this is an object called a rectangle. Okay, it's an instance of class rectangle. But this node itself is another object, which contains, among other things, a rectangle. So let's define a class for this. Let's just call it node. And it's going to have two fields. As usual, we can call the first one data, and that's a rectangle. And then it needs a next field, which corresponds to the following node. So what type of object should next be?
Node.
It should be a node.
Oh,
We don't have to say struct. No more struct. Now this can look goofy if you think about it the right way or the wrong way, maybe. This can start to look like nested Russian dolls, right? Because we're defining a node, but it's got a node inside it. And what is this node? Well, it's got a node inside it. And that node's got a node inside it. And it can feel like something's wrong here, right? But the reason this works is because these are actually pointers, right? They're references to a node. So we're defining a node, and when we say this is actually, it's not like we take another node and we shove it into this lower half of this node. We're really just putting in a reference to it.
It's the same with the rectangle, right?
It's the same with the rectangle, right? But we can think about it as, here's a rectangle, here's a node, right? But sometimes we want to think about it as these things pointing to another node, okay, without having to use the language of pointers. So there's the eyeglass symbol, which says watch out for that. All right, well, let's make a constructor for a node. So, and when we construct a node, basically we want to stick a rectangle in it. So let's just go ahead and make a constructor that takes an argument. Let's just call it D. Let's call it R for rectangle. And to construct, all we really want to do is set the data field equal to R and set the next field equal to null, right? So we can say data equals R and next equals null. And that's probably our whole node class.
That only constructs one node.
So it,
That only constructs one node.
that constructs one node, right? So this isn't the list yet, this is just these objects that we're putting together into a list. Okay, so let's write this as we go.
So it defaults when you're actually constructing the node, it will always default to be the last node in the list. In this case, since it is being set to null, or it's
No, we're just constructing a node. We're going to do whatever we want to do with the pointer later,
okay.
right? I mean, we don't need this. We could do this in our list code, but we don't have anything else we can set it to, so we're just setting it to null so we know its value is
And we
null.
don't have any like, access to other nodes.
Yeah.
So there's that.
Or it would be easier to type on the again. There's check it. So the only construction and you on.
All right, so a real quick rectangle class here. Just a constructor and a toString for printing it out. Yeah, I forgot string. I always forget string. That's what happens when you use Eclipse. Oh, and I got 2 errors. All right, and I posted a note on Canvas about the keyword this. So people seem to understand what this is, which is great because I always have trouble explaining it. And this time people seem to understand how to use this. But I wanted to mention you're not required to use the keyword this. For example, down here I can just say height. And the only variable named height that's accessible from this line of code is this one right here, which is the one that I'm interested in. Now I could also say this dot height, and it would refer to this also. But if I had a local variable in here named height, and I just said height, this would be accessing the local variable. And if I wanted to access this one, I would have to say this dot height. Okay, so the scoping always works with the thing that's most closely scoped to your line of code. That's the variable that's accessed. This is a keyword that lets you get around those scoping rules and get to the one that's declared as part of the class itself. So that's why I'm not using this in here. Okay, so let's define our node class. So we've got a data piece, which is a rectangle, and we've got a next field, which is a node. And that's all I think we had for our node. We went through this in yesterday's afternoon class, and I posted the code for that one, and that version of the code has lots of comments in it, so this one's not going to have a whole lot of comments. So you got two versions you can look at then. All right, so there's our node. So let's build our linked list. And let's just call this LL. So we're building a linked list. It's a collection of nodes, right? There's one piece of data we need to have in this linked list in order to be able to make use of this collection of nodes. And it's some kind of handle to typically the first node, right? We got to have a way to get to the beginning of the list. Once we're at the first node, we can follow these next pointers and get all the way through the list and so on. But we got to have a way to find the first node. And that can be just a variable inside our LL class. So let's make a variable. It's going to be a type node. And let's just call it first node. And if we want, we can go ahead right here and make that null. And I'm not using a sentinel node here. We could. It's up to you in PA2 whether you want a sentinel or not, but let's not use a sentinel. Let's just say that an empty list contains no nodes, and a list with one node has a single node, and so on and so forth. So an empty list is a special case where first node is null. Okay, and that's going to be a flag to us to say there's nothing in the list is empty. And we're going to have to check for that flag before we try to do something with first node, because if we say first node.data, we'll get a null pointer exception from the JVM. Okay, so let's make an add method. Let's make an insert. And let's insert a rectangle into this list. And let's insert at the beginning of the list. So we'll always squeeze something into the very start of the list. So this will come out like a stack. The last thing that you insert will be the first thing in the list. So we've got two cases here. So if first node is null, then the list is empty. In which case we just want to set first node to our new node. Agreed? Okay, what if first node is not empty? What if there's already stuff in this list? So let's
If we're putting it right at the beginning, then we would build a new node that's pointing to the node that's already in here.
exactly. So let's do a node temp equals new node. And we'll construct with that rectangle. Okay, so if our first node is null, then our first node should just be this node we constructed. Otherwise, we want to insert into the beginning, so we need to do two things. Our new node needs to point to, so here's our new node. Here's first node. Here's temp. This is null. Here's our rectangle. So we need to change this to point here, and then change first node to point to our new node. Everybody okay with that? So to insert a new node in the beginning, we need this new node to point to the old first node, and then we need first node to point to this new node. And so the order of these can be important.
Do we have to set it up like this with PA2?
Do you have to say what?
Do we have to set it up like this with PA2?
Set what up like?
Where you insert at the beginning?
No, you don't want to do this for PA2.
Okay.
So for the word list in PA2, you want to insert in the right place so that everything's alphabetical.
Okay.
For the position list, you always want to add to the end
Yeah.
so that the numbers are in increasing order.
It'll be the same as how we did it in 222.
Yeah. So I'm going at the beginning because it's different from what you're going to want to do. All right, so temp dot next equals first node, and then set first node equal to temp. That should be your whole insert. I'm putting this in the wrong spot. Okay, so here's our linked list class. So first nodes are pointed to the first node, it's equal to null, which means the list is initially empty. So here's our insert routine. So we're going to insert a rectangle. So make a temporary node. If first node's null, then just change first node to point to our one and only node. And we could return here if we wanted. So let's insert before first node. So temp dot next equals first node, and first node equals temp. So there's your whole insert code. And it's only this long because we don't have a sentinel. So we have a special case of going from an empty list to a non-empty list. But it hopefully reads a little more smoothly than C, right? We're making a new node. And we either set our first node to be that, or we set this to point to our old first node and then point to this.
It's a lot more user friendly.
Yeah. All right, so let's make a traversal routine. So how are we going to print? It's exactly the same thing we did in 222. we're going to have a temporary node that's going to refer to whatever the first node in our list is. And if that's not null, we'll print out the data, and then we'll change this to be the second node. If that's not null, we'll print out the data, and then we'll change to the third node. And we'll just keep going until we change to something that's null, and then we're at the end of the list and we're done. So data structure wise, this is stuff we've done before. So it's a short while loop. So start with the first node. If that's null, there's nothing to print. Otherwise, print its data, move to the next node, and then repeat. And the main point of confusion in this kind of thing is, should this be temp or should it be temp.next? And should I be printing temp or temp.next.data? And should I be moving to next at the bottom or at the top of the loop and that kind of thing? There's a lot of variations that are possible. Some of them work, some of them don't. Okay. Since we don't have a sentinel, it's pretty clear we want to start with the first node, and we do want to print that node's data. And if the list is empty, then we don't want to go into this loop at all. So that sort of forces this and this, and forces this at the bottom, and then just run through the logic, see if it makes sense. But if you do it some other way, same thing, just step through it, play computer, see if it makes sense. All right, I think this is all we need for a linked list class. And we don't have a constructor because we don't really need to do anything in a constructor. Right, now we could, in our constructor, set first node to null, but we can also just do it in the declaration of first node. So that should be fine. So let's make a main program. So there's an empty list. So that's all we need to do to construct a linked list. And now we just want to add a bunch of things to it. So let's add a 3x5 rectangle. And let's add a 7x9. And let's add a 12x16. I'm doing rug sizes here, I think. All right, so we got 3 rectangles in our list. And then let's print out our linked list. And then we'll exit. So we're inserting at the beginning, so we should be printing from largest to smallest. We should print 12x16, and then 7x9, and 3x5. That was an interesting message. I have something goofy going on.
You want to do
Oh, we
insert?
called it insert, yeah. I called it insert.
I just did that on my
Yeah. Yeah, it helps to be consistent. All right, so we're compiled up. Let's go ahead and run it. All right, there's our linked list traversal.
If you wanted to turn that into a string, would it, like the linked list to return string, would there be an easy that one string in a while.
Sure. So
I just don't know how you do that.
So let's make a two-string method for LL. So this is going to be another traversal routine, right? So temp equals our first node. And output will be our output string. We'll just initialize it to be an empty string. And well, temp is not null. Let's do output equals output plus temp.data plus, we'll just throw some spaces in there. And temp moves to temp.next. That's the end of our while loop. And then we'll return output. So we're building a running string called output. Each time through, we just concatenate to the end of it the next piece of data. And if temp.data was an integer, this would just be tacking integers on, right? If it was a string, it would just be tacking those strings together. It's a rectangle, so it's tacking those rectangles together. And the reason it's tacking on 12 by 16 is because that's what a rectangle prints as, because of rectangle's two-string method. So we'll just print out list with system out print line.
And that's how it defaults in Rects.
That's how it defaults to printing list now. But we still have a list.print method available. Options are good. But here again, I mean, we've taken all this machinery that we've written, 3 or 4 different classes, and it's all sort of encapsulated inside this, and this, and that, and that. So now if we want to use a linked list of rectangles, right, we don't have to muddle up our code with, mallocs and calls to functions and things like that. We just say list is an LL, and if we want to add something, we add it. If we want to print it, we print it, right? It's really like modular.
I wonder you were pushing that a lot.
Yeah, yeah. So if we wanted to change insert to add at the end of the list, would that be hard?
Shouldn't be.
Be a bit harder. Would it be doable?
Oh, shouldn't be.
Right? I mean, we can already get to the end of the list because that's what we do in our traverse. We just keep setting temp equal to temp.next until temp is null. So we know how to get to the end of the list, and so we can do that thing in insert, but instead of printing, just keep moving down until temp.next is null. And at that point, set temp.next equal to whatever your new node is, and you're done. Set your new nodes next to null, which we're doing in the constructor. And so for the word list, you need to keep things alphabetized. So that's a little harder still, because you need to do this 2-pointer thing, right? right? Where you march through and you remember the previous node and the current node, so that when you find that you've gone too far, your previous node tells you what you want to insert after, right? And you sandwich in between those two. And you've done exactly that, I think, with every linked list you made in 222, except for the stack implementation, stack and queue. And for the position list, we're always inserting at the end of the list, so that's more straightforward. So, suppose we wanted to take this code and turn it into a linked list of integers instead of rectangles. What in this file would have to change, and how would it change?
Could you just swap out every instance of the phrase rect with int?
Pretty much, right?
Yeah.
Up here, we're constructing a node, so that's just a node. Down here, when we say insert, instead of passing a rect, we'd pass an int. And I think that's the only place that a rect even appears, is in the insert. So if we just change that to an int, this would be perfectly set for a linked list of integers.
So this linked list is compatible with any data type.
Pretty much. And if you look at your node class, we've got a few more rects in there,
Oh, yeah, that's
but it's 2 instead of 1. And if we change those, we got a linked list of integers. What if we wanted a linked list of strings? Of course, it's exactly the same thing. Change a few rects for ints, change a few ints to strings. So we'll talk more about this in a later class, but there's a concept of a generic. And a generic is a way to sort of capture this observation and make use of it. So we can define a generic linked list that's agnostic to the particular type of data you're working with. And we can write this code, but instead of saying rect or int, we'll put in something like a variable. And the main program that uses this class gets to specify what that variable should be and basically say, I would like an LL of ints, or I would like an LL of rects or strings. And it's called a generic, and we can create this generic class, and when you use it, you just put in angle brackets what type of variable, what type of object you want. And everywhere that we have that in here, it basically plugs in whatever the constructor specified. And now we've got even more general purpose code. So we don't have to write 15 different linked list classes for different types of objects. We can write one. And a lot of the stuff in the libraries that we'll use, array lists and hash maps and things like that, are built with this idea of being generic. So it's an even greater option for code reuse. And we can write our own generics. So we'll see how to do that. All right, so other questions?
Do generics do something like a linked list of requests? Maybe support?
Yeah, they'll support anything.
Okay.
Yeah. Which is really nice because trying to code a linked list with some goofy kind of object can be goofy. So yeah, you can make a linked list of hash maps if you want. And we do things like this, right? And what's nice about being in an object-oriented language is that you don't have to get bogged down with the details of, so what should my data type be and what should it be pointing to, right? All of that's sort of bundled for you. You can stop worrying about it. It's a hammer, You don't have to worry, is this like a hardwood handle? Is it a softwood? Is it going to, warp over? It's just a hammer, right? You use it to smack nails. So Java's got like 10,000 hammers.
nothing like that in C, is there? That's just nicely announced.
Like generics?
Yeah.
The closest you can get is the preprocessor, I think. And in the preprocessor, right, so number sign defines and things like that, you can define what are effectively macros, and they can take arguments. So you could make a macro that would build a linked list, a set of linked list routines, right? And you could tell it what type of variable and it would plug it in. It's not often done, I don't think, but it would kind of get you there. But it's definitely, it would feel like a kludge, I think, to most people.
Couldn't you just have like void pointers and then
Have what?
void pointers and then when you're using a list, you just always use the same thing. You just have to mentally track it.
Yeah, as long as you stick to pointers to your things, it doesn't probably care if it's a pointer to a rect or an int. Yeah, that's true.
It's a pretty nice feature to have.
Yeah. All right, so that code's on the server.
You have to like you said yourself little commands to upload things.
I was thinking last night I should make one because then I could like timestamp it and stuff,
That's awesome.
but I'm just SFTPing it. All right, so let's hop back into Eclipse.
Critical.
Oh, it's already running. Good. You've got to delete me. All right. What can we say about Eclipse in 6 minutes?
Okay, question.
Yeah.
This kind of a step back. But
That's fine.
PA1,
Mm-hmm.
once is determined fraction class, right? Doesn't need the main or whatever.
Fraction class and whatever else you need to make the fraction class work, but it does
Okay.
not need a main.
Cool.
Yeah. And put those in just a plain old zip file.
Okay. Also, regarding to Linux, if you have two separate class files, how will you compile them together? Make one program. Does that make sense?
Two separate class files.
Does that make sense? So let's say you have a main class, that's our main set now or whatnot, and then you have, like, let's say a fraction class. How do you
Mhm.
compile those two particularly run the other file?
So if you compile each one, you get a .class file.
Okay.
And if I say Java main, right, and it needs a fraction.class, it'll look in my current directory. And if it finds a fraction.class, it'll use that.
Oh,
So
okay.
just having them in the same directory kind of puts them all together.
Oh, so it's not like C where you need to like compile it.
No, because in C we're actually building an executable image. So we've
Okay.
got to somehow get all these objects together. In Java, it's really just having access to the right class files. And under the normal default, it'll just look in your current directory for any class file that you need. But you can also specify, when you say Java, there's a bunch of switches. One of them is the class path. And you can say, where should I look for class files that I need? So you could have your fraction class in another directory, but still sort of point to it,
Okay.
and then just have your main program. You can also create something like a tar file, it's called a jar file, that has a bunch of class files inside, and just say, run my program, right, execute this class, but here's a jar file with class files in it you can use, and it'll pull them out of there also. And so you can have lots of different things with lots of different hierarchies, but put them all in just a single entity, and it's a .jar file. Yeah.
I haven't really experimented much with the options on Eclipse.
Mhm.
But, I like a dark workspace when I'm doing programming. So
Yeah.
they have those sorts of options.
Yeah.
Where would I find those at?
So one generally useful thing, it's under help for some reason, install new software. You can find lots of options in here.
Okay.
And you can choose where you want to download from. And
Like a skin.
yeah, you can get skins and you can get plugins and all kinds of things. And if you put in a site, so this is just the default one. application. So these are just updates, right? So, and you can search in here and find different things. And then you can select them and install them. So, but you can Google and find like skins, there's dark themes and so on. And I can't remember the name of the VI plugin, but there's a VI plugin that works pretty well. You just have to disable some of the standard shortcuts. And then, I don't know if there's an Emacs plugin. So there's an export option, and if you right click on your package name, you can say export. And if you say general archive file, this will export your current project in a way that lets you import it into an empty workspace and recreate the entire project. So, because your project is more than just your .java files, it's also got manifest type things that tell Eclipse what the parts and pieces are of it. So you can export from Eclipse and then you can import it back in. So that'll be the submission details, but I'm not going to rush through that in 60 seconds. So instead I'll let you out 60 seconds early. How about that? All right, so I'll be around tomorrow. If you want to work on things, come on in during class time. Otherwise, I will see you another time.
And PA1 you want .java and .class or just .class?
PA1?
Yeah.
Just put your .javas into a zip file.
Just .java.
Good, you
Yeah.
have to make sure compiles first.